but this is where it gets a little bit complicated, these last two skills. So I think it's worth just going through this from the beginning. So this is weighted means. And obviously you can follow along in the syllabus notes. If you don't know how to do that, just let us know in the chat. A record shop had 567 customers in June with a mean spend of £18.74, 893 customers in July with a mean spend of £23.14, and 725 customers in August with a mean spend of £24.05. What was the mean spend of all the customers in June, July, and August? Okay, so we'll go through. So this was the more, this was the kind where they actually tell you how many items are in each subset. And then the question, yeah?
I was wondering if you were going to share your screen.
Yeah, thank you. Yeah, I am. Thank you. Yeah, I'm glad somebody pointed that out and you didn't all just sit there for an hour not telling me that I wasn't sharing my screen. Every week I feel like an old man with my technological failures, but here we are. So yeah, thank you. Can you see it now?
Yes.
Yeah, okay, good. So, and can you hear me okay?
Yes.
Okay, good. So this was the first question. Was there's kind of two different weighted means type of questions, although they're not fundamentally that different. So the first type is where we're told how many items are in each subset of the total. So this first question, the total set of items is all the customers from June, July, and August. But that is made up of three subsets. The first subset is all the customers in June, which was 567 customers. The second subset is all the customers from July. And then the third subset is all the customers from August. And so this type, we're told how many items are in each subset. The second type is we're not actually told the actual numbers of items in each subset, but we're told their proportions. So that might be percentages or their decimals, or it might even be their ratios. And then you'd have to use some of your ratio skills that we've already learned to convert those into maybe percentages or decimals. So in the second question, the total set is all the properties in a town. And then the three subsets, it doesn't have to be three subsets, by the way, it's just these two questions both have three, are houses, flats, and masonettes. And we're told that 50% of the properties are houses, 35% are flats, and 15% are masonettes. And then we're told the mean age for each subset, and we have to work out the overall mean age for all the properties. Okay, so let's start with the first question. And I'm going to actually try and put these side by side so that we can keep an eye on the question while we do it. So if we just kind of visualize this a little bit, I'm going to do this in quite an abstract way. So if this is like all of the customers, then within that there are like three subsets: the June customers, the July customers, and the August customers. And we know how many items are in each one. So there's 567 in there's 567 June customers. There's 893 July customers, and there's 725 August customers. That's meant to be an A. Okay, so, and we're told the mean spend of each group. Now we want to know what's the mean of like all three of these groups put together. And in fact, this diagram maybe is not the best way to represent it because it makes it look like there's something other than there's items that aren't in one of the sets, but that's not the case. So we could say, in other words, we want to know what's the mean of all three groups, like that. That's what we're trying to find out. Okay, so what we can't do is we can't just take the mean of the three means. So we can't just take £18.74, which is the mean spend in June, £23.14, which is the mean spend in July, and £24.05, which is the mean spend in August, add them together, and then divide by 3. The reason we can't do that is because the number of items in each subset is different. So there are only 567 customers in June, for example, whereas there are 893 customers in July. So in other words, this July mean spend is going to have more of an impact on the overall mean than the June mean spend is. So we don't want to treat these three means, the means of the three subsets, equally. We want to treat them with different weights, different importances. And so this is why it's called a weighted mean. And so the way we do that, in fact, I might just pull this over here. So, so we take the mean of each subset and multiply it by the weight of that subset, which just means the number of items in that subset. So in June, 567 times £18.74. And we do that for all the subsets. And then we add all those numbers together and we divide by the total number of items in all subsets. So in other words, we find the total spend, in this case, for June, because that's what you get when you multiply the mean by the number of items. We find the total spend for July, we find the total spend for August, add those all together, that gives us the total spend for all 3 months, and then we divide that by the total number of customers, and that'll give us the overall mean. So you can see that here. And as I mentioned before, you don't actually need the brackets when you put this into the calculator in terms of between the different, around each multiplication, because the addition will be done afterwards anyway. And then you divide that by the sum of the weights, so the sum of the number of items in each category. So you can see that here, you could do this using the fraction button on your calculator. So you put in £18.74, or just 18.74 times 567 plus 2314 times 893 plus 24.05 times 725, and then over 567 plus 893 plus 725. Okay, so when we do that, we actually get 22.30, £22.30. So that is the mean spend for those months. Okay, now the second question, I know just at the point where we kind of decided to abandon the session last week because of the problems with the connection, one of you had said in the chat that you were unclear of a certain aspect of what we were doing, and I was about to explain that. So let's just go through this one carefully from the beginning, and hopefully it will make sense. So in this question, our 3 subsets are houses, which make up about 50% of the total number of properties, flats, which make up 35%, and maisonettes. In fact, let me draw it more like this, and maisonettes, which make up about 35%. And so then this kind of here represents all the properties, and we want to know what's the mean for all the properties, the mean age in this case. So we're told that the mean age of the houses is 97, the mean age of the flats is 27, and the mean age of the maisonettes is 24. Okay, so what we do, first of all, I'm going to tell you what we do, and then I'll just go back to the theory and just explain it a bit more carefully. So what we do is we do a weighted mean, but we use the percentages as the weights, because we don't know the actual number of houses, flats, and maisonettes, but we know the percentages. We know it's 50%, 15%, and 35. Sorry, 50%, 35%, and 15%. I actually drew it slightly wrong. So we just use the percentages as the weights, and then as the total of all the weights, we use 100%. Now, this was the point that I was going to clarify, because somebody asked, why don't we use 3? Isn't that the kind of sum? So 3 is the number of subsets, sorry, that we have, but it isn't the number that we want to put on the bottom, and I'll come back to that in a second and try and explain that a bit more clearly. But for now, I'm just going to tell you that as a fact. So obviously we can't type percentages into the calculator, or at least most calculators don't have a percentage button, or most scientific calculators at least. But it doesn't matter, because we can just convert them to decimals. So instead of 50%, we have 0.5. Instead of 35%, we have 0.35, 15%, 0.15. And instead of 100%, we have 1. And it's really important to remember that 100% is equivalent to the number 1, not the number 100. And that gives us a mean age of 61.55. Now, we don't actually need to divide by 1, because dividing something by 1 just gives itself. So we could actually just type this into the calculator like so. And we also don't need any brackets within this line, because the multiplications will be done before the additions. So this would actually be a really quick way to do this type of weighted mean question. Alternatively, we could just use this form and just drop the percentage symbols. So instead of 50%, we just use the number 50, 35% we use 35, and so on. Now, this doesn't mean that in general in maths, you can think of 50% and 50 as equivalent to each other. They're not. In fact, 50%, the number which is equivalent to 50%, is 0.5. That's why we use 0.5 here. However, it turns out that for this particular calculation, all that matters is the relative proportions of these weights. So, for example, we could use 100, 70, 30, and 200. So we could just double all the numbers, and it would come out exactly the same. It just matters what the proportion of the different weights is, and therefore it doesn't matter whether we can get away with just dropping the percentage symbols and putting it in like this, which is fine, as long as you remember that it doesn't really mean that 50% and the number 50 are the same thing. So we can just put it in like this, over 100, and we get the same answer. Okay, so then going back to the question of why do we put 100 at the bottom, or 1 when we're using decimals, why don't we put 3, since there's 3 sets? So to try and explain that a bit, let's make up some numbers for what the actual number of each type of property might be. And remember, we don't know what the actual numbers are. We're not told that. But for example, let's say the total number of properties was 200,000. So the number of houses in this example would be 100,000, since it's 50%. And the number of flats, which is 35%, would be 70,000. I'm actually just going to put 70k to save time and space. And the number of maisonettes would be 3,000. No, I missed out a 0. 30,000. 30k. Okay, so let's actually just put 100k, just so they're all written in the same format. Okay, now just to reiterate, I've just made up these numbers to match the percentages. These might not be the numbers. It could be 200k, 140k, and 60k, or anything. It could be 50k, 35k, and 15k. Anything that matched these percentages is what it could be. But the point that I'm making is that when we're doing these, when we do this type of question, we don't use the actual numbers. We use the percentages that represent those numbers. So instead of using the actual number of houses, which is 100,000, we use the percentage that represents that number, and that's 50%. Instead of using the actual number of flats, which is 70,000, we use the percentage that represents that number. That's 35%. And instead of using the actual number of maisonettes, we use the percentage that represents that number, which is 15%. And therefore, we have to follow the same principle and be consistent with that. Instead of using the actual number of properties, which is actually 200,000, we use the percentage that represents that number. And that percentage is 100% because it's everything. It's all the properties. It's these three percentages added together. So that's why we use 100% as a percentage. We don't use 3 because 3 is just the number of subsets. If you added more subsets, it wouldn't make a difference to the number that we should put at the bottom. We just want to use 100%. So in the same way, when we did the first question, what we put on the bottom was the total number of items in all the sets. We didn't put 3, which is the number of subsets. We put the total number of customers. And in the same way, when we use percentages, we use the percentage that represents the total number of properties. Hopefully that makes sense. Let me know if anybody's still unclear about that, and I can try and find a different way to explain it. So that brings us on to the last skill, which is quite a wordy one, but not actually that complicated once you see some examples. Well, a little bit complicated. Given the mean of a set of values, the total number of values, the means of one or more subsets of the values, and the number of values in each subset, calculate the total and mean of the remaining values. So it's basically what it's saying is, what if you were told the overall mean, but you weren't told one of the means of the subsets, or the mean of one of the subsets, I mean. And so it's kind of the same type of question, but instead of finding the overall mean, you're given the overall mean and you're given all but one of the subset means, and you have to find the remaining subset mean. So it'll be a bit clearer when we look at example. So a company has 528 employees working in 3 different cities: London, Manchester, and Edinburgh. Okay, the mean salary of all the employees is £29,587. There are 248 employees in London, and their mean salary is £32,456. There are 106 employees in Manchester, and their mean salary is £27,983. What is the total salary of all the employees in Edinburgh, and what is their mean salary? Okay, so let's have a look. So the overall employees is 528 people. That's the total number. And the mean salary for all the employees, we're told. And that number is 29,587. Now, I'm not going to write it here because it would take too long. But I'm just going to say a tick to say that we've been given that information. We also know the number of employees in London, which is 248. So I'm just going to roughly guesstimate it's about that much. So that's 248. And we're also told the mean of that subset. The mean salary of the employees in London is 32,456. So we have been told the mean of this subset. Okay, we're also told there's 106 employees in Manchester, So something like this, 106. And we're also told their mean salary. We're told their mean salary is 27,983. So we want to know how many employees. Well, we can easily work out how many employees are in Edinburgh. We're not actually told, but we can work that out very quickly because it would just be 528 minus these two numbers. So it's just the difference between 528 and the sum of these two. So we'll do that a bit later on because we don't need to do that straight away. And we're also not told the mean salary of all the employees in Edinburgh. So that's what we're also trying to find. And we're also asked to find the total salary. Now, if we find the total salary and we know the number of employees, then we can find the mean salary because it's just total salary divided by number of employees. Okay, so, and when I say total there, I mean total for Edinburgh. So straight away we can notice that the mean for London is higher than the overall mean, and the mean for Manchester is a bit lower than the overall mean. And so, well, actually, that doesn't necessarily tell us too much about what Edinburgh would be in this case, because it could be either side of the overall mean. But if they were both above or both below, then you'd know that the missing one must be the other side. Anyway, it's not too important. So what we need to do is, first of all, work out what is the total salary of all the employees. Not the mean salary of all the employees, but the total salary. So in other words, how much does the company pay per year in salaries, in paychecks, to all of its employees across all the companies? And we've learned how to do this before. We just multiply the number of items, in this case the number of employees, by the mean, the overall mean, and that will give us the total salary for all the employees. And to save us time, let's have a look here. So the total salary of all the employees equals the mean salary, 29587, multiplied by the total number of employees, 528, and that gives us £15,621,936. Okay, we're also told that there are 248 employees in London. Oh, sorry. So we can also work out the total salary of the London employees because we know the number of employees and the mean, and we can work out the total salary of the Manchester employees because we know the number of employees and the mean salary. So London, we follow the same process, multiply the mean by the number of people, and you get £8,049,088. And Manchester, we do the same thing, multiply the mean by the total number of people, and we get 2,966,198. Okay, so now we know the total salary of all employees, we know the total salary of London employees, and we know the total salary of Manchester employees. So clearly the total salary of Edinburgh employees must equal the total salary of all the employees minus the total salary of London employees minus the total salary of Manchester employees. So in other words, it's the difference between the total salary of all employees and the sum of the total salaries of London and Manchester, because everyone that doesn't work in London and Manchester works in Edinburgh. That's explicit in the question. Okay, so when we do that calculation, we find that the total salary for Edinburgh employees is £4,606,650. So that answers the first part of the question. Now we need to find their mean, and as I mentioned earlier, in order to find the mean, we need to divide the total, which we've now worked out, by the number of employees. So now it's time to work out the number of employees, which is just 528 minus 248 minus 106. So total number of employees minus number of London employees minus number of Manchester employees, and we get 174. So we've now worked this out. So now we just have to divide the total Edinburgh salary by the number of Edinburgh employees, and then we get the mean salary for Edinburgh, £26,475. The mean salary of all the employees in Edinburgh is £26,475. Okay, cool. So that brings us to the end of the averages skills. And actually, I don't think I'm going to do any more syllabus, any more parts of the syllabus. I'm going to add any more because I think everything we haven't covered now is stuff that is better learned by just doing questions, because the only thing that we haven't really covered is like how to interpret graphs and tables and bar charts, pie charts and things. But we've done all the actual maths skills. And I think if we just do lots of questions, you will get the hang of getting the data from the questions. Because I think that's the thing that we haven't really explicitly gone through, although we've done it in the practice questions that we've done, is actually like filtering out all of the irrelevant information in a question, like something like this, and finding the key information. And I think the best way to do that is just to practice once you've learned the skills. But first, you do need to obviously learn all the skills that we've covered so far. So even if you understood me going through it, that isn't the same thing as really having it at your fingertips. And some of you may now be at the point where you're like, okay, yeah, I get all this. Some of you might be more like, oh, I'm not really quite sure, so I don't, some of it's a bit fuzzy. And that's mainly just going to be, the difference is how much maths experience and recent practice you had coming into this course. But what I really, really recommend that everyone does is go through the question packs, starting from the beginning, and do every single question. And I know some of you have been doing that. And yeah, go through from the beginning. And if you get it wrong, so say, I don't know, you're doing one of the questions, the answers are underneath, so you go and check the answer, and let's say you got it wrong. Then you've got to ask yourself, do I understand now that I've seen the answer? And if you do, then great. Then you've learned from your mistake. That's really useful. You can practice the rest of them. If you don't understand even once you've seen the answer, then you probably want to go back to the syllabus notes and actually reread that section and see if you can figure it out. And if you can't figure it out, then that's why we've got our Slack channel where you can ask me any questions that you're stuck on. And obviously we've still got a couple more weeks of this course, so please do take advantage of that. I would be really delighted if I knew that people were using these. And if you've then gone through all the question packs and you've really sharpened all of this stuff, then you will find that when you then go and look at numerical reasoning test questions, you will have all of these individual skills at your fingertips, and all you'll be practicing is just interpreting the question, figuring out which skills to apply, and then accurately carrying that out, which is much, much easier to learn once you've learned the individual skills. So I really recommend taking the time to go through that. So anyway, enough rambling for me. Let's carry on, but let's actually do some practice of averages specifically. So I'm actually going to put Menti up on my tablet. So if you will go to menti.com now, I will give you the code in a second. Okay, so the code is, so I'm doing it on my tablet, which is why I can't copy and paste the oh, sorry, there was a question I've just seen in the chat. So for me, I think I usually use the long method, which is not really helpful to my time management skills, as then I don't get to finish answering questions. Okay, so what I would say is, first of all, in order to be able to do something quickly and accurately, you have to first learn how to do it slowly and accurately, and then speed up. You can't just start, like, you're never going to get there if from day one you're putting yourself under loads of time pressure and being like, do this as quickly as you can, whilst also learning and getting to grips with the methods and the skills and so on. You need to start off doing it slowly, and just don't time yourself. I know I'm putting a time limit in these sessions, but that's partly just because it's a group situation. But when you're on your own, just take your time and don't worry about the time pressure. I know obviously in the actual test, time is one of the things you're being marked on, but you first need to just learn how to do it slowly. And once you get the hang of it, you will naturally start to speed up anyway. And then getting that extra speed will come to you very easily. This is kind of true with any skill, really. If you can get really good at doing it slowly, it's not much extra work beyond that to get good at doing it quickly. Adding the speed in afterwards is not difficult. The other thing I would say, just in terms of long methods versus short methods, if you go through the syllabus notes as I've written them, I have at various points quite often pointed out faster and slower ways of doing things on the calculator. This is one of the reasons that I've emphasized this throughout this course, which is not something I usually care about when I teach maths. So do have a look at that and try and figure out other things that you're unnecessarily putting brackets on things and stuff like that that could be slowing you down. So yeah, I think just practice, and yeah, initially, no, I wouldn't say shortcuts, but for example, in that previous example I had where it was a fraction over 1, you don't actually have to put that in as a fraction over 1, because dividing by 1 doesn't do anything. It gives you the same number you started with. So it's actually to do with your understanding. Yeah, I suppose in a way they are shortcuts, yeah, but it's to do with your understanding of numbers, and the more confident you are in your understanding of numbers, the more confident you'll be taking those kind of shortcuts. But yeah, like, the answer to everything is just practice. So, oh yeah, I was going to put the code in. So yeah, I can't copy and paste the link, but if you go to menti.com and then the code is 85421101. So if you could go and do that now so that we can do the questions interactively, and then if you could click on the little the like thing at the bottom of the page, just so I know you're there.
I don't think the like thing's at the bottom of the page.
What does it say on the...
It says, what is the mean?
Okay, great. Well, let's just assume that people are in then. Okay, cool. So I'm going to give you 1 minute for this one. Okay, so just enter your answer and off you go. Okay, 15 more seconds. Okay, so the answer is 2.3. So well done to the 2 people got that right. 3 people, third one just came through. So all we have to do is add all the numbers together and divide by the number of numbers. There's 7 numbers in this case, and so when we do that, we get add them all together, it gives us 16.1. Divide that by 7, we get 2.3. Okay, so that was just straightforward calculating the mean. This one, there's a little bit more going on, so I'm going to give you 2 minutes for this one. Off you go. One minute. Thirty seconds. Ten seconds. Okay, so the correct answer is B, 26,193. So well done. 2 people got that right. 1 person said C, and so C is the answer you get if you just take the mean of these 2 numbers, and that's not the right thing to do in this case, because what we need to do is take a weighted mean. So I'll explain that a bit more in a second, but first of all, let's just have a look at the question. So what is it's a bit weirdly worded, this question, but let me just read it out. So what is the average income for a household from Scotland and England combined in 2012? So it's a bit weird because you might interpret it as a household from Scotland and England combined, like some kind of combined household, but it actually means what's the average income for a household based on all of Scotland and England combined in 2012. But the thing that all of you did right was you identified that we need to use the 2012 data. So this is a really standard numerical reasoning test. Thing is that they will give you irrelevant information, and you have to ignore the irrelevant information and identify the relevant information. So the reason we can't just take the average of Scotland's mean and England's mean, or take the mean of Scotland's mean and England's mean, is because there are a lot more people. Well, there's quite a lot more households in England than Scotland. So we could only do that if we had exactly the same number of households in Scotland and England. So in other words, you could think of it like this. We need to figure out what's the total income of everyone in Scotland, or every household in Scotland and England, and what's the total number of households, and then divide the total income by the total number of households. And how do we find the total income? We multiply the number of households by the mean, and that would give you the total income for Scotland. Do the same for England, that would give you total income for England. add those together and you get the total income for Scotland and England, and then divide that by the sum of 2.5 and 3.9, which is the number of households, and that will give you the mean. In other words, it's a weighted mean that we need to calculate. So whenever you have, so just because you might be thinking, okay, so I know how to calculate a weighted mean, and I know how to calculate a regular mean, but how do I spot when I need to calculate a regular mean and when I need to calculate a weighted mean? So the answer to that is you need to calculate a weighted mean whenever you have a big set of data, well, I'd say a larger set of data, which is made up of two or more subsets. And the number of items varies between one subset and the next. So in this case, there aren't two items, there are two subsets of items. So the actual number of items, well, there's 2.5 million items in the Scotland subset, and there's 3.9 million items in the England subset. In this example, the items are households. Okay, so once the average, and by the way, if they just say average, you have to assume they mean mean rather than mode or median. It's quite common that people just use the word average for mean. If they want the average income for a household, then the individual item is a household. But we don't have two households. If we just had two households and it said what's the mean, then you would just add the values together and divide by 2, the number of households. But we don't have two households. We have millions and millions of households. We have 6.4 million households. So what we want is the total income divided by 6.4 million. Okay, now, when we do this, we don't actually need to type in 2.5 million, i.e. 2,500,000, and we don't actually need to type in 3,900,000, because as I mentioned before, weighted means only depend on the relative size of the weights. It doesn't actually matter what the actual numbers are. So coming on to shortcuts, which we've been talking about, one shortcut that we can use here is to just use 2.5 and 3.9 rather than typing out 2.5 million. So that's one shortcut that we can use. So now, if you were doing this on your calculator, you would press the fraction button. So on the top, we would do 2.5 times 24,186 plus 3.9 times 27,480. So notice again, I'm not using brackets here, which is another shortcut of sorts, over 2.5 plus 3.9. That's our weighted mean. Oh, calculator thinks I mean power of, oh, I know. We have to use the asterisk on the keyboard, and then it does a little dot. And then we get £26,193.28. If you're still a little bit shaky on when to use mean and when to use weighted mean, have a look through the question pack and look at the different types of questions the type of questions that I've put for the weighted mean. It's always, there's a big set that's made up of multiple subsets. Okay, so moving on. Okay, so have a go at this one, and I will give you 2 minutes. Off you go. One more minute. Twenty seconds. Okay, do you need more time? Do people need a bit more time, or are you just completely stuck? Or have you already answered and it's not showing up on Menti? You don't get it. Okay. Okay, cool. So let's just go through it then, because we've only got 3 minutes. So the correct answer is... Oh, there were answers. Sorry. Some people had answered. It just wasn't coming through. So the correct answer is A, which is 10 runs. Okay, so the average score of 11 batsmen of the school cricket team is 20 runs. So again, average, we have to take that to mean mean. And notice straight away, there's something that could throw you off in this question, which is the batsmen are numbered 1, 2, 3, all the way up to 11. But these numbers are not the number of anything. It doesn't mean there's 7 of something. It's just the numbers of the batsmen. They could be called A, B, C, D, E, F, G, or it could have the batsmen's names here. So that could be a little bit potentially confusing, because it might make it look like these are subsets of a bigger set, but they're not. The number of items is just 11. There's 11 batsmen. So we're not dealing with weighted means here. Okay, now the average score of the whole cricket team is 20 runs. So we've been given 10 of the players' scores, but one of them is missing. So how many runs did the 11th player score? Okay, so we can work out the total number of runs for all 11 players by multiplying the mean by the number of, the mean, which is 20, by the number of players, which is 11. And that tells us that the total number of runs was 220. And then all we have to do is subtract all the values that we know, which is 10 of the 11 values, and then what will be left over will be the number of runs of the 11th player. And we don't have to do -0, because -0 doesn't do anything. So we just take these away, and that will leave us with the number of runs for the 11th player, which is -15 -18 -9, and that gives us 10. So this tells us that the 11th player scored 10 runs. Okay, so the correct answer is A. So if you've been through the question pack, then you definitely will have done that type of question, because it's this one here. However, the challenge might be identifying that it is that type of question. So the first thing to do is just be able to do each skill, and then one of the next things that you need to work on is actually identifying the skills that are required in each question. So you have to recognize that this question here is this type of question here. And once you have done lots of practice, well, the more practice you do, the better and better you will get at spotting what needs to be done in each case. Okay, so we will finish up there, and then next week we will do some more practices.